Hi students, this is Alex here. In this video, they have given a tightly stretched string with fixed ends x is equal to 0 and x is equal to L. And initially it is at rest in the equilibrium position. And it is set vibrating string by giving a velocity of lambda x into L minus x. And we have to show that the displacement is this entire expression. Using all this, we are going to write the initial and the boundary condition. The first is y of 0 comma t is 0 because at the position x equal to 0, it is fixed end, so there is no displacement. So for t greater than 0, y of 0 comma t is 0. In the same way, the other end, y of L comma t is also 0 for t greater than 0. And third is initially it is at rest in the equilibrium position, so y of x comma 0, which is also 0, and this is 0 less than x less than L. And fourth condition, it is given a velocity, so dy by dt at x comma 0 equal to lambda x into L minus x, and this also 0 less than x less than L. So these are the conditions we have. Now let's take the wave equation. The wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. Now, the suitable solution for this equation is y of x comma t equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Now let's use the first condition. So using the first condition, which is y of 0 comma t is 0. So wherever x is there, we have to put 0. So y of 0 comma t becomes, when I put 0 here, cos 0 is 1, so we left with only c1. When I put 0 here, sin 0 is 0. So totally c1 alone is there. And the remaining terms are c3 cos pat plus c4 sin pat. Now this value is totally 0. So 0 equal to c1 into c3 cos pat plus c4 into sin pat. And now this term c3 cos pat plus c4 sin pat not equal to 0, as it is defined for all t. Therefore, the only option is c1 must be 0. So we take c1 as 0 here. Now using c1 0 in our solution, y of x comma t becomes c1 is 0. So this term won't be there. We have c2 sin px into c3 cos pat plus c4 sin pat. Now using the next condition, that is second condition, y of L comma t is 0. So x is replaced as L. So y of L comma t equal to c2 sin pl, then c3 cos pat plus c4 sin pat. Now this value is 0. So 0 equal to c2 sin pl into c3 cos pat plus c4 sin pat. Already we discussed this term cannot be 0. And here this c2 also cannot be 0 since c1 is 0. Already c1 is 0. Again from the same term another constant cannot be 0. Therefore the only option left is sin pl equal to 0. It means when sin theta equal to 0, we get theta is equal to n pi. So this pl is like theta, so pl is n pi. So from this, p is n pi by l. So our solution is y of x comma t becomes c2 into sin px. So p is n pi by l then x into c3 cos pat. So n pi by l at plus c4 sin pat. So sin pat can be written as sin n pi by l at. Now we are going to use the third condition. So using third condition, that is y of x comma 0 is 0. So t we have to replace it as 0. So y of x comma 0 will become c2 sin n pi x by l. Then when t, if I substitute as 0 here, cos 0 is 1. So we left with only c3 and sin 0 is 0. So totally we have only c3 and this value is 0. So 0 equal to c2 sin n pi x by l into c3. Already we discussed c2 not equal to 0. And in the same way, sin n pi x by l also not equal to 0 because it exists for all the x. And only option is c3 must be 0. So when c3 is 0, we get a solution, that is y of x comma t equal to c2 sin n pi x by l into c3 is 0. When c3 is 0 here, this term won't be there. Then we have c4 into sin n pi at by l. So c4 into sin n pi at by l. Now we combine these two constants as cn and we have only sin n pi x by l into sin n pi at by l, and here we have y of x comma t, and we are going to take summation for this 1 to infinity. And now to apply the fourth condition, we need derivative. So dou y by dou t of x comma t, we are going to differentiate this with respect to t. So the constants cn is written as it is, and sin n pi x is also, n pi x by l is also constant because we are partially differentiating with respect to t. So x is constant, and this differentiation is cos n pi at by l into n pi a by l. Now let's take the condition, fourth condition. Using fourth condition, that is dou y by dou t of x comma 0 is lambda x into l minus x. This is what given here, lambda x into l minus x. So wherever t is there, we have to put 0. So this will become dou y by dou t of x comma 0 will be summation n is from 1 to infinity and cn sin n pi x by l as it is. When I put 0 here for t, cos 0 is 1 and n pi a by l we have. Now let's take this as this constants outside, n pi a by l, we take it outside the summation, and n is equal to 1 to infinity, and here it is lambda x into l minus x, this dou y by dou t of x comma 0. And here we have cn, and the cn is actually, we can take it as bn into sin n pi x by l, and this is the half range sine Fourier series. This is half range Fourier sine series. So we can find Bn using the formula 2 by L integral 0 to L f of x into sin n pi x by L dx. So we are going to substitute f of x, that is Bn equal to 2 by L integral 0 to L, and lambda I can take it outside because it's a constant, x into L minus x into sin n pi x by L dx. So we have Bn like this. Now we are going to use Bernoulli's method to find its integration. We are going to take this as u and this as v. So u is x into L minus x. Actually it is Lx minus x square after expansion, and v is sin n pi x by L. So u dash is L minus 2x, u double dash is minus 2, and u triple dash will be 0, and v1 will be minus cos n pi x by L by n pi by L, and v2 is minus sin n pi x by L by n pi by L whole square, and v3 is cos n pi x by L by n pi by L whole cube. Now Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So bn becomes, outside we have 2 lambda by L. So let's write that 2 lambda by L, u which is Lx minus x square into v1. v1 is minus cos n pi x by L by n pi by L, minus u dash which is L minus 2x into v2 is minus sin n pi x by L by n pi by L whole square plus u double dash which is minus 2 into v3. v3 is cos n pi x by L by n pi by L whole cube. Now we have limit from 0 to L. So we completed the substitutions. Now let's substitute the upper limit. So wherever x is there, we have to substitute the L. So by doing so, Bn, the first term, let's write the outside term 2 lambda by L. The first term L into L, L square minus L square is 0. Similarly, when I put here L, I get sin n pi after cancelling the L. Sin n pi is 0. So we have only the last term remaining, minus 2, and this is cos n pi, which is minus 1 whole power n by n pi by L whole cube. Minus, when I use the lower limit 0, here both are x, so it is 0, sin 0 becomes 0. Again we left with only the last term, so which is minus 2, cos 0 is 1, then we have by n pi by L whole cube. Now let's rewrite this 2 lambda by L, and denominator we have n pi by L cube common, so it is n cube pi cube by L cube, so L cube I take it here, and here we have only minus 2 into minus 1 whole power n, then it is plus 2, and we can take the 2 also outside. It will become 4 lambda L cube by L into n cube pi cube. After taking 2 common, we have minus of minus 1 whole power n plus 1. We can cancel this, it becomes L square. So finally we get Bn as 4 lambda L by n cube pi cube, and this we will rewrite. Let's write this one first, then this one second, because it's a negative term. We are writing it as a second term. Now when n is odd, like 1, 3, 5, now 1 minus of minus 1 whole power 3, this will become 1 minus of minus 1, it will become 1 plus 1, which is 2, and already there is 4. So Bn will become 8 lambda L by n cube pi cube for n odd. If it is even, when n is even like 2, 4, 6 like that, 1 minus of minus 1 whole power 2 will become 1 minus 1, which is 0. So this will be 0 when n is even. So this value exists only for the odd value of n. Now we are going to substitute this Bn in our solution. That is y of x comma t is, we already had a constant outside the summation. Now we have to write the summation from odd till infinity, and the constant which we had outside is n pi a by L. So it will be better if I take this Cn and n pi a by L together as Bn. It is easier to substitute. So Bn equal to Cn into n pi a by L. So let us not write this constant outside. Since we had Bn, I have to replace the Bn after finding from the integration, and Bn is Cn into n pi a by L. So here Bn is Cn into n pi a by L. So when I get Bn as 8 lambda L by n cube pi cube, that is equal to Cn into n pi a by L. So using this, I can get the Cn. Cn will become, we have to cross multiply. So 8 lambda L square, because this L will get multiplied with this, and divided by this n pi a will get multiplied here. So n power 4 pi power 4 a. So in our solution here we have Cn. So the Cn should be replaced. So when I replace it here, it will be 8 lambda L square by n power 4 pi power 4 a. Along with that, we have sin n pi x by L, sin n pi at by L. So let's write it here, into sin n pi x by L into sin n pi at by L. There is a small correction. This is L square. After cancelling L cube and L, we get L square, and this is again L square. So when I replace for Cn, it will become, after cross multiplication, L cube. So it is 8 lambda L cube by n power 4 pi power 4 a, and rest of the terms. Now to change this odd to 1 to infinity, every n is replaced as 2n minus 1. So now we get a final solution, y of x comma t equal to, the constants 8 lambda L cube by pi power 4 a is taken out. Now summation from n is from 1 to infinity, and 1 by n power 4 is 1 by 2n minus 1 whole power 4, and we have sin 2n minus 1 into pi x by L into sin 2n minus 1 into pi at by L. This is our solution for the given problem. This is what given in the question, to prove 8 lambda L cube by a pi power 4 summation 1 to infinity 1 by 2n minus 1 whole power 4 sin 2n minus 1 pi x by L into sin 2x minus 1 pi at by L. That we got it here.